Hello everyone. In this video, we're gonna discuss about image classification. Have you ever wondered how CCTV cameras classify the human beings and objects and other cars? No, right? It's simply the object detection, and if we want to classify into different categories, that's image classification. So, image classification is a process in which we feed the model, a trained model, an image, and it is capable to convert or to predict the output of that image. So, and this image classification has various algorithms like naive Bayes algorithm, decision tree, uh, SVM, and it is not limited to this algorithms only. We have convolutional neural networks, which is very huge field, and it has powerful algorithms which can give better accuracies than the naive or native algorithms. So let us now, in this project, we are gonna discuss about the wildlife animal classification, in which we have a data set from Kaggle, and it has the images of six animals: cheetah, fox, hyena, lion, tiger, and wolf. So we're gonna train the model based on these images and see what are the results. So we are gonna use four algorithms and one CNN to compare the results. First of all, we will import all the libraries included in this project. Then we're gonna specify the link or the URL for our dataset, which is stored into our drive. And as we can see, we have our dataset on the drive. So we need to import it to the Colab environment and then fetch all the images. So this functions does that job for us. So in this all data variable, we have all the images. Later, we are splitting the images into training and testing uh, sets, training, testing, and validation sets. After that, we are resizing the image into 2 to 4 by 2 to 4 size in order to maintain the consistency. Then we are normalizing the data, as you can see here. And first of all, the first algorithm we're gonna test is the random forest classifier. So we are training the model with n estimators is equal to 150 and max depth is 5. So based on that, we get a model which has an accuracy of 85%, which is pretty much good. And here is the confusion matrix that we got, and then testing it on our validation set. As we can see here, an image of uh, hyena is there, but it has predicted fox, so that's a false prediction. Let us see the next prediction. Over here it has corrected accurately. The next algorithm is KNN. Over here, after training with n neighbors, or which is equal to 8, we get a accuracy which is not so good. It's like 46%. And after training it on the validation side, as we can see here, we have a false prediction of fox since it's tiger, and later, as we can see, it's hyena. So the trained model with KNN is not that good. Later, let's try with the decision tree. After training, we got an accuracy of 84%, and let's test it on the validation set. It has predicted fox, and over here it has predicted fox. Next algorithm is naive Bayes algorithm, in which we were able to achieve an accuracy of 39%, and this is a confusion matrix. As we can see, it has very much false prediction over here. So this is the prediction of this image, this is the prediction of this image. So while comparing the output, as we can see, random forest and decision tree has compared to better accuracy than all the rest of them. The next we are gonna see is the CNN. In this, we are gonna use ResNet 50 as a base model. Since we are doing a transfer learning, we need a base model for that. And uh, upon that base model, we're gonna add some more layers so that it can be suitable for our data set. Over here too, we are using the make data frames function to fetch the images and then resizing it. So as we can see here, we have done the resizing of the images and generated the validation and testing images of 6 classes. So next we're gonna see the sample images. As we can see here, these are the sample images that we're gonna train our model. So over here we are importing the ResNet 50 model with the classes 6 and weights ImageNet. Next we are going to add some layers onto it, like this is the pre-trained model we downloaded. Then we have added 3 more layers. After trial and error, this is the one we are getting the maximum accuracy. This is the summary of our model. Later we're gonna train our model with the learning rate of 1 raised to 10 raised to minus 3, and we are training this model for 4 epochs. After 4 epochs, we can see the loss has been dropped considerably and the accuracy has been increased to 99.43%. So this is the graph for our model. With this information, we were able to learn about the image classification and perform it using various algorithms. So by this video, we were able to achieve our goal and thus learn about the machine learning algorithms.